Hey folks, I just want to quickly get into a core important concept around ML, particularly the three core pillars on which most of the ML algorithms stand, and the metrics that seem to be very confusing. At least it was confusing to me. I'm going to be covering accuracy, precision, and recall. Now, these are three core important pillars, core important metrics that a lot of data scientists, a lot of people use everywhere just to be sure how accurate a model is, how precision, what's the precision level of what's the precision level of accuracy for every class of data that you have, including what's your recall for every class, right? So without further ado, I'm going to quickly jump in. I created this notebook just to present this concept to you. I've already run it just to be sure that I'm not making any mistakes, and I will then take over and also present you the Google spreadsheet where I'll go a little bit more deeper into it. Right. So what we have here is the ground truth, the truth that, or the true data, right? The baseline data or the truth data that we call. And here are the predictions that a model is supposed to make. So let's assume a model has made these predictions. And now we need to figure out how good or bad the models are and how the classification predictions seem to be. Right. Now, if you look at it, these are a bunch of metrics, and we will come to this in a while after I present the notebook to you. A lot of this will then become very clear. Similarly, I have a data set where I have predicted fewer apples as opposed to this model. And from that perspective, the model and accuracy levels have changed, got down to 57% as opposed to the 76% of accuracy that we have. So with that, moving over to the spreadsheet where the same numbers have been copied over just to make it a little bit more easy for us to understand. I'm just going to move a few things here. So here, if you see, this is your truth table, right? This is exactly the same truth data set that we had here, right? Now from here, what I am going to do is I've copied the prediction values here, and we're going to compute the accuracy, precision, recall values. But before that, what does accuracy mean? So accuracy really is how well your model is in predicting overall population of data sets as opposed to be very specific at a particular class. So accuracy is all about how well your model is overall. Precision is for all the values that I have predicted to be a particular type of class. So for example, for all the apples that I have predicted, how well my prediction was. Like how many apples did I really identify as opposed to how many labels or how many classes did I like I called out apple, but they really were not apple, right? So that's precision. How precise is my model? And precision, recall are always at a class level. Accuracy is always at a model level. Now moving over to recall, how many apples were there in the data set and how many was I able to correctly identify? So that's recall. Precision looks at how many apples did I do overall on the data set versus how many apples did I identify that really were apples. So that's how you should really look at recall. Now, if you look at it here, I have correctly identified apples, oranges, lemons, so on and so forth. There are 16 such cases, and there are 5 negative cases where it's an apple here and an orange on this side. So if you really look at it, if you do a 16 divide by 21, which is your entire data set out here, you'll get the model accuracy to be 76%. However, if you look at apples, and again here it's not that different. I mean, you won't really understand that much, and hence I have a case where we flipped the data set a bit. But if you look at just this set, so how many apples were there? So if you really look at it, there were 6 identified apples of the 7 total data set, right? Or 1, 2, 3, 4, 5, 6, 7. So there were 7 predictions made of apple, of which 6 were absolutely true, right? 1, 2, 3, 4, 5, 6. So 6 were truly done out of the total 7 that were identified as apple. So hence, if you look at it, 6 divided by 7, which is 85%. Similarly for lemon, similarly for orange. Now, if you go to recall, what we've done out here is how many from the 8 apples that were there. Right? These are 8 apples, 8 values. How many did I correctly identify? So if you look at from these 8, I correctly identified 1, 2, 3, 4, 5, 6. So 6 by 8 results in 75%. So just to summarize, accuracy is how well my entire model is on the data set. Precision is for every class, what is my what's the predictive score? Like, how good am I able to predict that this is an apple? Similarly, for recall, from the data set that is only apple, how many have I been able to identify apple? So that is what accuracy precision recall is. Now, if I move over to a different data set, you'll get to see same data set here, but the prediction value has changed. And now my accuracy is 12 and the negative values are 9. So if you see 12 divided by 21 will give you 57%. So my accuracy has changed. Now, why has my accuracy changed? Because I have misclassified a bunch of apples as oranges, and we'll get to that. Now, if you look at apple, what does this mean? It's a precision of 1. It means whenever this model identifies an apple, it always is an apple. So it's precise. But the problem is it's misidentifying a bunch of other apples out there, and hence the recall value is also very low. So out of the, how many are these? Out of the 8 values, only 1 was identified. So 1 by 8 is 12.5%, which is exactly what this number is. Similarly, orange. Let's look at orange. The precision of identifying orange is 42%, or let's say 43%. How? If you look at it, there are, I'm just going to choose this. Just going to highlight orange so that it's easy. Right? So there are 14 such oranges that we've identified. And out of that, if you really look at an overlap of this, 6 of them, 1, 2, 3, 4, 5, 6 of them have been correctly identified out of the 14 that we predicted to be true. So hence the precision of this is 6 by 14, which is about 42% or 43% or 0.429. Similarly, when you look at lemon, here, if I just look at lemon, right? Out of the data set of, we have 1, 2, 3, 4, 5, 6. So there are 6 lemons identified, of which only 5 are really lemons. 1, 2, 3, 4, and 5. So hence the precision for identifying lemons is 83%, 5 by 6. But the lemon, the recall is also 83%, which means this model does an amazing job at balancing precision recall between lemon and, it does an amazing job to balance between recall and precision. When you look at an apple, it misclassified several apples as oranges. But when it identified it as an apple, it was 100% sure that this is an apple. So which means the precision is high, but the recall is low. So we need to figure out a balancing score. And we'll talk about it in the next session of how do we balance, what should we do. We'll talk a little bit more about F1 scores, etc. Next, when you have an orange, it's misclassified oranges quite a lot, but your recall is true. So when from the sample set of orange, it did a great job identifying most of them as oranges, but it also went ahead and classified apples as oranges, and hence the precision is low, the recall is high. So we'll have to figure out a way where we improve the precision on apple so that automatically the precision of orange also improves, because this is what it is. And again, this is just a very simple example. On a larger data set, it is even much more complex. So a lot of this analysis needs to be done time and time again. With every experiment, you need to review this. Right? So from that perspective, the average accuracy seems to be, or not the average, but the accuracy of this model is 57%. The average precision is actually, this is a sum, this is an average of these 3 numbers, 75%, and this is just 60%, which means there were many more items that could have been used for classification or for making predictions, which didn't get done correctly. So this is what it generally means. Now let's go back to this. We'll see the same scores here as well. Right? If you look at it, 57% accuracy. Now, when you look at this, it'll get a little bit more clear, right? Apple, only 1 identified as apple. Orange, 6 of them identified correctly, but then 7 apples were also classified as oranges. So this is a confusion metric, very important to understand how the general trend seems to be. And if you compare this with the confusion metrics of the model that works beautifully well, which has at least a 76% accuracy, you'll get to see a beautiful trend line here to say, 6 apples were identified as apples, 1 of them as lemon, and this is how the distribution seems to be. So I hope this makes sense to you. I'm happy to take more questions, and if you have any more questions around accuracy, precision, recall, happy to create another video as well. But for this is all I had. I just wanted to create a short bite of what somebody asked me, and also I used to struggle quite a lot with this earlier when I started my machine learning journey. So thought, let me just share it with you. Thank you so much. Bye.